Hello, Algebra 2. Here we are with 4.4 Day 3. We're just going to try to wrap everything up, put a nice bow on it, bring everything together here that we've talked about. So our first thing we're going to be doing today is actually solving with I, taking little baby steps into solving with imaginary numbers. And we have to think about, where does I come from? Remember that I, imaginary numbers, come from the square root of our negative numbers, with the simplest one being the square root of -1. So let's quickly review here some of these other square roots that we are now able to do. So the square root of -4, positive 4 would have been 2, -4 is going to be 2i. Sometimes they don't come out quite as clean. The square root of -50 we're going to have to break apart to the square root of -25 times the square root of 2, we'll get 5i square root of 2. Okay? Now let's take that and go forward in solving. If we had 5x squared plus 5, we're going to subtract 5. 5x squared now equals -5. Okay, if we divide by 5, x squared equals -1. Previously, we would be stuck. We would not be able to move forward. Now, with our new knowledge, we are able to solve. We would square root both sides and say that x equals I. Okay, go ahead and pause the video here and give the other one a shot. Alright, let's see how you did. We're going to subtract 96. Then we're going to divide by 6. For -16. And then when I square root, we'll get 4i. Okay, so that's one type of problem that you'll be able to do now. Here's another type that we're going to look at. These look really scary, and I know they can be intimidating because there's all those letters. It is not that bad. Don't worry about them. Okay, so we have 9 plus 12i equals 3x plus 4yi. So here we have our complex number with the real and imaginary part. And here we have another complex number, real and imaginary part, but these have variables. Alright, notice that this is the real part, and this is the real part. So if these two complex numbers are equal to each other, the real parts need to be equal. So 9 needs to equal 3x, and then the imaginary parts need to be equal. 12i should equal 4yi. Okay, so we divide by 3 over here, and we'll get 3 for x. And if we divide by 4i, we should be getting 3 for y as well. So if I were to put 3 in for x and y, 3 times 3 is 9, that would match. 4 times 3 is 12i, that would match. Okay? So you're just looking at the real parts together and the imaginary parts together. Okay, this next one can be even a little bit more intimidating. So I have 2a minus 4b times I plus a plus 5b minus 7. That should be just a minus 7, not a times or anything there. Minus 7 equals 8 plus 58i. So we got a lot going on. So all these have a's and b's except for this minus 7. So let's keep all the a's and b's on one side. We'll move all of the other numbers to the other side. So I'm going to add that 7 over. And we'll have 2a minus 4bi plus a plus 5b equals 15 plus 58i. Okay, so now just like last time, we're going to group these up. Where are our imaginary numbers? Where are the real numbers? Okay, so we have two complex numbers. This side's flipped. They put the imaginary part first. We could have flipped it around on our second line here. So the real part is 15, and the real part over here, the non-imaginary part, would be a plus 5b. So I know that a plus 5b equals 15. The imaginary part, 2a minus 4b, needs to equal 58 for our imaginary parts to match. We have two equations with two variables. What could we do? You could solve with substitution, you could solve with elimination, you could throw these into matrices, whatever you wanted to do here. Just the way I have them written side by side here, it might be easier for me to do substitution. I'm going to subtract that 5b over, and now I'm going to put that over here. So instead of a, now I have negative 5b plus 15. So we're going to have negative 10b plus 30 minus 4b equals 58. So we have minus 14b equals, subtract our 30 over, we'll have 28. Divide by negative 14, we should be getting negative 2 for our b. Put that negative 2 back in. A equals negative 5 times negative 2 plus 15. That's going to be a positive 10 plus 15. A is going to be 25. Okay, so that was the other opposite end of the extremes. Relatively pretty easy. Had a little bit of work to do, and we had we had to use a different solving technique there at the end. We had to use substitution or elimination. It wasn't as straightforward as this one. And there'll probably be some problems in the middle of those two difficulties on your homework as well. Alright, then we just have some review problems. So go ahead and hit pause and try out those top two. Alright, let's see how you did. So we have multiplication in our first one. So we'd FOIL those out. We're going to have 3 minus 4i plus 6i minus 8i squared. 3 minus 4 plus 6 is going to be a plus 2i. I squared is going to be a negative 8. I squared is a negative 1. With a negative 8 makes it back to a positive 8. And we'll have 11 plus 2i. Over on this side, this is subtraction. So subtraction will distribute that negative. So that's going to be a negative 4. Now it's going to be a positive 2i. So 3 minus 4, or 7 minus 4 is 3. 3i and a positive 2i. It's going to be plus 5i. Okay, we have a review problem with factoring. You're going to have a couple of review problems on factoring today. So go ahead and hit pause and give that one a shot. Alright, so we have a number in front, and it's not possible to factor out a 2 out of all three parts. So we're not going to be able to factor it out. So we have to do a times c, front times back, what multiplies to negative 24, and adds to 5. Okay, we're going to get a positive 8 times a negative 3. would be negative 24, and 8 minus 3 would be 5. So now we have those numbers. Remember, we have to come back with our a and divide. So this one worked out, it equals 4. This one doesn't work out. Okay, so the one that does work out, positive 4, we have x plus 4. And in our other parentheses, okay, this is as far as I can reduce this fraction. So now you take the bottom, the denominator slides up in front, 2x, and then we have a negative 3. So those are our factors. We're solving what would make each factor equal 0. Well, if x was negative 4, this one would equal 0. And when we have one of these, remember our trick, opposite of the back divided by the front. Positive 3 divided by 2. Ta-da! Okay, last set of problems that you're going to have on homework tonight. Is it a perfect trinomial? Is it a perfect trinomial? What does a perfect trinomial look like? Well, let's look at our first one together. What multiplies to 36 and adds to 12? 6 and 6. So this would have been x plus 6 times x plus 6, or x plus 6 squared. Perfect trinomial, because it was a binomial squared to get there. Okay? How about you try the next two and see if those would be perfect trinomials. Okay, what's going to multiply to 9 and add to negative 6? Negative 3 and negative 3, so yes, this would be a perfect one. It comes from x minus 3 squared. What multiplies to 64 and adds to 20? 16 and a 4, so those are different. This is not a perfect square trinomial. Alright, that's it for notes and review. You should be set up for success here on your homework. We're on page 250, 36 through 47, 75 through 81, and 84 through 86. Alright, have fun.